So friends, let's recap what we just did. Let's recap what we just did. I want to draw a nice parallel between what we just did and everything we've done so far. And it's all about estimation right now. Alex kicked it off earlier today by talking about estimating the population parameter. So essentially, what Alex said very succinctly, here is what we did last week, this blue arrow. If you're trying to estimate a proportion, which we call little p, you take little p hat, you apply that, but don't write this down if you don't want to. I mean, it's really not the point. So, I want to focus on that last sentence momentarily here. Momentarily. Oh, and sometimes I put M-O-E instead of M-E. Can you guys live with that?
Yeah.
Sometimes I give the O an O. Alright. So, here's the deal. You pick the Z based on how confident you want to be. You pick the Z based on how confident you want to be. After you've constructed the interval based around that, you then essentially say, I am that confident that the value I'm looking for is between this and this. Hopefully that makes sense symbolically, what's going on numerically. So this is the low end of your confidence interval, p hat minus the margin of error. This is the high end, p hat plus the margin of error. This is what you're estimating, and you're 95 or 99 or 90 or 68% confident that it's between those two values. Is that fair? What does it mean again? What does 95% confident mean again? Oh, good, good. Wait, don't tell me. Hang on. McKinnon. I was going to say McClellan. That's the last name. McKinnon, thank you. Dude, it gives a true standard deviation. Without using the word standard deviation, which is a perfect use of it, what's another definition of confident? 95% confidence. I'll give you a hint. It has to do with the idea of replicating studies. 95% of studies done the same way will do what? Will, on average, catch him.
So that would be the 68%. If we wanted to do the 98%, what would it be?
Oh, you have to change this right here, Linda. This margin of error is a general margin of error. You adjust it by adjusting the Z. If you want 98% confidence, I think you're going to have to go to something like 2.55 or something like that for a Z.
What I was saying, the formula that you put down there is pretty much for 68.
No. It's for any confidence. If I see what you're saying, sister. If you change this to standard error, it would be 68% confidence. Margin of error depends on your Z value. If you make this 1, then it's 68% confidence. 1 standard error. If you make it 2, it's 95%, because of what McKinnon just said. If you make it 3, it's like 99.5%. So that's why I'm making this as general as I possibly can. Is that fair?
Yeah.
Good question, good question. Let's see how we parallel that for averages. Notice how I put center and spread. What would the center for averages be? If you're estimating an average, which would be an unknown mu, what would your center be? I asked the question at the poorest timing because now it's showing up on its own. Ha ha! X bar! I have to adjust the timing on this one. It's a relatively new sheet. Now, check this out. Somebody just asked the question I was going to prompt. So, everybody okay with this? X is the center. Everybody okay with this statement down here?
Yeah.
It's a logical connection between where we were and where we are. You're estimating the average. In this case, it was the average weight of a Del Taco half-pound bean and cheese burrito. That came out all sideways, I apologize. But you're 95 or 99 or 98% confident that it's between the low end of the interval. As Nick pointed out over there, we feel totally fine about the half-pound bean and cheese burrito because even at the lowest end, it's still bigger than 0.5. So it's between the low end and the high end. Everybody okay with this right here?
Yeah.
Good, and somebody over there is getting very, very insistent. What the hell is T?
Yeah.
Good! Good. Because we're used to that being Z. What the hell is T?
Just another word.
Yes, but why the hell is T? This is the next question. Why the hell is T? Why are we not using Z there? Why is it called T? Well, I want you to sit back and take in a bit of a history lesson to talk about why that is T. T is the accepted distribution that is used when you're talking about averages. Z, yes, for proportions. It is accepted. It is what is currently used in the world for estimating proportions. But Z is not used for, even though we did over here, and you'll see momentarily why it's okay to have used Z over here. You'll see why momentarily. But a more common used variable is T. And I want to show you why. I want to show you